Greetings, everyone. Today we are going to explore factoring polynomials, which sounds very familiar because we've already done a whole unit on this. Did a bunch of it in the last unit, and now we're going to do a bunch in this unit. So keep factoring because I want you to be a level 3 factoring ninja. For reference, you should still have that foldable back from unit 4. As far as factoring, that would be very helpful if you forget any of the rules. Just a quick review, remember that you only need to jot down the slides that have a pencil in the corner. We're going to work through a bunch of examples in your own notebook. So just a refresher to talk this out, remember that factoring is a way to break apart a polynomial or pieces that are being multiplied. Our strategies of factoring are going to be the same as always. This is a review, but what we're looking for is we might have some higher order polynomials. And so our solutions will look a little different and our factoring might look a little different as well. So let's get to work. Example 1, remembering greatest common factor. So remember that we always want to take a GCF out of every polynomial if we can before we get to factoring. So in this example, if you want to jot this down because there's a pencil in the corner, I can factor out a 25. Can also factor out x squared. Remember, you can only factor out the least amount of x's that you have. By factoring out 25 from 50, I have 2. Factoring x squared out of x to the 4th leaves me with x squared. Remember that anything divided by itself is a 1, so make sure you account for the fact that there was a term there. All right, for example 2, take a second to jot this question down. We're going to revisit group factoring. Remember when you have 4 terms that are in this sort of standard form for a polynomial, you first always want to check for GCF. In this case, I don't have a common factor of x because of my constant on the end. And I don't have a common number I can take out. 3 divides into 30, 18, and 15, but does not divide out of 25. 5 divides into 30, 25, 15, but not 18. So it looks like we should have something to take out, but we don't. So we're going to move forward with our steps for grouping. Group the first 2, group the last 2. Take the GCF out of your first 2 factors. I definitely can divide out an 18 squared. And then I need to decide a common factor for a number that I can divide out. In this case, I know I can definitely take out a 3, but there's something a little bit bigger. I can actually take out a 6. You want to take out the largest, the greatest common factor. So in this case, that leaves me with a 5x minus a 3. Second set of parentheses, notice my sign. I'm going to take out a negative 5, which leaves me with a positive 5x and a minus 3. If you didn't take out a negative, then you'd be stuck because your factors wouldn't be common. So let's take out that common factor of 5x minus 3. That leaves me with a 6x squared minus 5. In this case, it is not an equation, so I'm not setting it equal to 0. I'm just factoring. Take a moment to jot down example 3. You just need the 2x squared minus 5x minus 12. One way we're going to expand this from what we've learned previously is we're just going to stick to quadratics in the sense of an x squared and an x for my exponents. We might have a 4 and a squared, we might have a 6 and a 3, and it might keep going up from there, maybe an 8 and a 4. We still follow the same procedures as far as using the AC method. So quick review of the AC method. A times C, B goes on bottom, negative 24, negative 5. Factors that multiply to get me 24, but have a difference of 5. Take a second to think about that. In this case, we have an 8 and a 3. I have signs, so I'm going to have a -8. Let's check our work. -8 times 3 gets me to -24. -8 plus 3 gets me to -5. So that now replaces my middle term. I now have a -8x and a positive 3x. We have 4 terms, so we are going to group. Take out a common factor of 2x. Take out a common factor of positive 3. I've got the same thing twice, so I know I'm on the right track. Factor out the x minus 4, and all you have left is a 2x plus 3. All right, please take a second to jot down example 4. First and always, check for a GCF. In this case, I can divide out a 4 and an x squared, which leaves me with an x to the 4th minus a 5x squared plus a 6. Let's take a look at the inside here. I have a traditional trinomial that I'm going to use AC for. Now make note, I have a leading coefficient here of 1. So as I do my AC, I have a 6 on top and -5 on bottom. To get these to work, I need to have a 3 and a 2. They would both have to be negative. Let's stop and use our check. -3 times -2 is positive 6. -3 plus -2 is -5. Now here's the assumptions we can start to make. With that leading coefficient of 1, we can skip our grouping steps because these factors end up being our factors. And our middle term ends up being our first term in our binomial. This is something we can start to rely on when that leading coefficient's 1. So let me show you the grouping steps that you can skip. If I was to use grouping, I would have x to the 4th minus 3x squared minus 2x squared plus 6. I would group. I'd take out an x squared. I'd take out a -2. And then you'd notice that's how I got to the x squared minus 3 and x squared minus 2. So when you have that leading coefficient of 1, jump ahead, make this process faster. And in the end, don't forget to bring down that GCF. Take a second to jot down this example 5. Perfect squares. So this was the last page in our foldable from the factoring chapter. Notice that the left side is a perfect square and the right side of the binomial is also a perfect square. And we have a minus sign. When those three all happen, we can just jump straight to perfect squares, meaning square root, that gives me a 4x squared and a 4x squared, gives me a 9 and a 9. And remember, your signs are opposite. Okay. Another way to think of this, if you struggle at remembering perfect squares, just make note that I'm missing my middle term. It's as if I have a 0x squared. If you want to fill in that term and use a C method, you could. It's just going to take a lot longer because you're going to have some big numbers. So that's the reason why we want to remember perfect squares, so we can jump straight to these factors. Take a second to jot down example 6. We have 4 terms, so what method are we going to use? All right, let's group the first 2 and the last 2. Divide out an x squared. Remember, anything divided by itself is 1. The second set of parentheses, I know I have to watch my signs, so I'm going to take out a negative, and I have to take something out, so I'm going to take out a 1. Got the same thing twice. That leaves us with an x squared minus 1 and an x minus 1. Now here's where we're going to take it a step further from the last unit. Take a look at this factor. That factor is also a difference of squares. We have to break that apart into 2 parentheses. It's a perfect square, and a minus sign. So x squared minus 1 is the same as x plus 1, x minus 1. And then bring down that factor we haven't used of x minus 1. Now here you'll notice I have x minus 1 twice. If you want to write it as twice, meaning write it as the quantity of x minus 1 squared, I'm okay with either way of writing that solution. All right, please take a second to jot down example 7. And actually, if we could pause the video here, I want you to try this one on your own, and then we'll replay to see where we're at. Okay, let's take a look. First thing I need to identify is that I don't have a GCF. I do have 3 terms, so I'm going to jump straight into AC method. I do have a leading coefficient of 3, so I can't make any assumptions yet. Factors of 30 that would combine to give me negative 11 would be negative 6 and negative 5. Double check your work. Negative 6 times negative 5 is 30. Negative 6 plus negative 5 is negative 11. So that breaks apart my middle terms into negative 6x and negative 5x. I now have 4 terms, so let's group. A common factor would be a 3x, which leaves me with an x minus 2. Common factor would be a negative 5, which leaves me with an x minus 2. Perfect, I got the same thing twice, so if I divide out that common factor, I have remaining a 3x minus 5. Neither of those have a squared, so I don't have to consider or take time to see if it breaks apart any further. All right, let's take a look and have a moment to jot down example 8. First thing I need to check is, do I have a GCF? And in this case I do. I can divide out a 2 and an x. So that leaves me with an x squared, a minus 4x, and a positive 4. I have 3 terms. I'm going to use AC, but notice again I have a leading coefficient of 1. So when I do this x and I have a 4 and negative 4 on bottom, 2 and 2, but in this case negative 2, negative 2. Let's check our work. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4, which means I'm going to skip those grouping steps, and I have an x minus 2 and an x minus 2. Bring down that GCF of 2x. So you can skip those middle steps if your leading coefficient is 1. You want to start seeing those factors automatically. All right, let's take a moment to jot down example 9. First thing, do we have a GCF? I do. I have a GCF of 3. If I divide out a 3, I have a 6x to the 4th minus 7x squared and a plus 1. I have a trinomial, so I'm going to use AC method. A times C and B goes on bottom. Factors of 6 that can combine to give me 7. Let's try 6 and 1. Gotta watch my signs. A negative 6 times a negative 1 is positive 6, and a negative 6 plus a negative 1 is a negative 7. So that's going to break apart my middle term. I now have a minus 6x squared and a minus 1x squared. Carry down that middle value of x squared. We can now group. I can divide out a 6x squared out of my first set, which leaves me with a 1x squared minus 1. I can divide out a negative 1 out of my second set, which leaves me with x squared minus 1. I have the same factor twice. If I write that out, I've got an x squared minus 1. If I divide that out, I have remaining a 6x squared minus 1. Don't forget to bring down that GCF of 3. But I'm not done yet. What else do I have to do? In this case, I have x squared minus 1, which is difference of squares, meaning x squared can be square rooted, 1 can be square rooted, and I have a minus sign. So this breaks down into an x plus 1 and x minus 1. Still have that GCF of 3, still have that factor of 6x squared minus 1. Now 6x squared minus 1 does not break down further because 6 is not a perfect square. So that leaves us with our final solution. So again, a quick review of factoring. Step 1, always GCF first. Then from GCF, you want to try group factoring if you have 4 terms, AC method if you have 3 terms, and remember, if A is 1, you don't have to do the full AC process. And again, in the end, if you have a binomial, check to see if that binomial is the difference of squares. As you finish jotting this down, you're going to be working on some worksheet problems on your own. So make sure you finish those up. Use your notes, use your foldable from that unit for help. And we're going to continue reviewing factoring and apply it in some new ways. Until next time.